This is a video on solving exponential equations without using logs. So without the logarithms. So for this method, we're going to make common bases. So check this out. If you had 3 to the power of 2, you could say that that is equal to 3 to the power of 2, right? You couldn't say that it's equal to 3 to the power of 3 because it's not. So 3 to the power of 2 is equal to 3 to the power of 2. So notice, like, when they have the same bases, their exponents must be the same for each side to be equal to each other. Right? That totally makes sense. So if I told you something like 3 to the power of 2 is equal to 3 to the power of x, you would know that x must be equal to 2. Because we just said it couldn't be 3 or 4 or -5. So we can make a statement that says if the bases of an exponential equation are the same, then their exponents must be equal. So if we had something that was like 2 to the power of 4x equals 2 to the power of 12, well, if we wanted to figure out what x is, we know that a whole exponent must be equal to 12. Since they have the same exact bases, their exponents must be equal to each other. So 4x must be equal to 12. Therefore, x would have to be 3 because 4 times 3 would equal 12. And I could do that by just solving this equation and isolating x. So now I know x would have to be 3. And I can just prove that by saying 2 to the power of 4 times 3 is equal to 2 to the power of 12, which is what we had. Okay, so let's try it with some crazier questions. Okay, so we have 3 to the power of x equals 27. Okay, so here our bases are not the same. So your first goal is to make the bases exactly the same. So could we turn the 27 into 3 to the power of something? Yeah. 3 to the power of 1 is 3. 3 to the power of 2, whoops, just kidding. 3 to the power of 2 is 9. 3 to the power of 3 is 27. That's what we were looking for. So now if we want to represent 27 as a base of 3, it would have to be 3 to the power of 3. So we just solved it. Now we can say that x must be equal to 3 because we know 3 to the power of 3 is equal to 27. Okay, let's try the next one. 2 to the power of 4x plus 1 equals 8. So the bases are, again, not the same. So I would look at the 8, and I know that 2 to the power of 3 is equal to 8. So I'm going to change 8, so it is now going to be written as 2 to the power of 3. So now I have the same base. So in order to solve for x, I can actually ignore the base, and I can just set the exponents equal to each other. And now I can just solve for x. So I'm going to subtract 1 from each side. So 4x equals 2 because I just subtracted 1 to get rid of these guys. And now I want to get rid of my 4, so I'm going to divide both sides by 4. So I'll get x is equal to 2 over 4, or I'll say 1/2. And if I wanted to just test that out, if I wasn't really sure, I could take my left side of my equation, 2 to the power of 4x plus 1, and I could input my x value. 2 to the power of 4 times 1/2 plus 1. So 4 times 1/2 would just be equal to 2. And then 2 plus 1 would be 3. And 2 to the power of 3 equals 8. So therefore my left side is equal to my right side. So I know my x value is correct. Okay, next question. This one's a little weirder because it has this fraction. So right away when you see this, you should be thinking like, is it possible for me to represent that as a base of 5? And as soon as I see the fraction, I think, yeah, that's possible. Well, I know that 5 to the power of 2 would be equal to 25. So 1 over 5 to the power of 2 would be equal to 1 over 25. And if I didn't want that to be a fraction anymore, I could just make it 5 to the power of negative 2. Because I know 5 to the power of negative 2 is actually equal to this. So I'm going to use my knowledge of negative exponents to make these guys have the same bases. And now that their bases are the same, I can just make their exponents equal to each other. Like so. So I'm just taking my exponent on my left and my right side and making them equal to each other. Now I'm just going to isolate x. So I'll get 2x equals 4. And then I'll divide both sides by 2, and I get x equals 2. And the last question. 4 to the power of x minus 1 equals 8 to the power of 2x plus 2. So like 4 and 2, I'm never going to be able to make them, like I can't turn the 8 into a base of 4. I can't turn the 4s into a base of 8. So I'm going to have to change both of them. And I can see right away that 2 to the power of 2 would be 4. And 2 to the power of 3 would be 8. So that's what I'm going to turn the 4 and the 8 into. And then whatever their exponent was, I'm just going to keep that in brackets beside the new exponent of 2 and 3. So these exponents are still in the exponent spot, but now they're just getting multiplied by a 2 and by a 3. Okay, so now that these bases are the same, I'm just going to get rid of them, and I'm going to make my exponents equal to each other. So I have 2 times x minus 1 equals 3 times 2x plus 2. Okay, now I'm going to get rid of my brackets by expanding. So I'll get 2x minus 2 equals 6x plus 6. And now I'll just get everything on the side I want it on. So I'm going to subtract 2 x's on each side, and I'm going to subtract 2 x's on each side, and then I'm also going to subtract 6 on both sides. So these guys go away, and I'm left with a negative 8. And then these guys go away, so I'm left with just a 4x. And then I'm going to divide both sides by 4. So x equals negative 2. And that's how you solve exponential equations. Okay, feel free to stop listening, or if you want to try these two, you could pause the video right now, try these 2 questions, and then play it when you want the answer. Okay, answer is, I'm going to rewrite the 16 as 4 to the power of 2. And now that my bases are the same, I'm going to make my exponents equal. Oops. I just expanded this guy. And I'm going to put my x's on one side. So I'll have 3x minus 2x equals negative 2. So I will have x equals negative 2. And then the other one, I can see that it's 1 over 81, which I know 1 over 81 would be the same thing as writing 3 to the power of 1 over 3 to the power of 4. So I'm going to write that as 3 to the power of negative 4 to make it not a fraction. And then I'm going to set my exponents equal to each other. So 4x minus 3 equals negative 4. And then I'm just going to solve for x. So 4x equals negative 4 plus 3. So 4x equals negative 1. Divide both sides by 4, and I get negative 1/4 for my final answer. The end.